Bismillahirrahmanirrahim. Assalamualaikum to all students. So now let's go to the second part of the MOSFET amplifier. Previously you have learned about how the hybrid pi model looks like for your MOSFET, right? So now let's go to the first MOSFET amplifier that we call common source. Okay, so how you're going to identify this is a common source? So you need to look at the output voltage. So as shown in this circuit, so we have what we call V out at your drain. So we call this one common source. Same with your common emitter. Where is your V out? So your V out will be at the collector. For the common source, your V out will be at the drain. Okay, so now as we are going to start the AC analysis, what you need to do first. So this is the circuit of common source. Why? Because you have the V out connected to the drain and your gate is connected to the input signal. So in order to transform this one to the AC equivalent, what you need to do first is you need to make sure your capacitor is short. So this one will be a short circuit and your VDD will be grounded. So okay, so how to transform this circuit to the AC equivalent? So your capacitor will be shorted. So let's start to draw from your VS. So this will be your input. You have your RS. And then your capacitor will be shorted. Now here you will have R2. So now what will happen to your VDD here? So your VDD here will be gone, right? And then it will be grounded at the top. So your R1 will be connected from the point A to ground. Same with R2, that is will be connected from A to ground. So you can equate your R2 is parallel to R1. So this will be your MOSFET, and then your source directly ground. What will happen at your drain? So your drain is connected to your RD and then goes to ground. So the total here will be grounded. So now let's look at the V out. So your V out will be connected to your drain. So this is what we call AC equivalent for your common source amplifier. Okay, so now what you need to do next is you need to transform this MOSFET to the hybrid pi model. So what will be the hybrid pi model for the MOSFET? Again, you have three lines. Here you're going to have G, S, and D. What will happen between G and S? You have what we call VGS. In between your drain and source, you have what we call a current source pointing down, and it is dependent. So it will depend on your VGS. Let's say in this question have VA or lambda, so you have what we call R naught here. So this is what we call hybrid pi model for your MOSFET. So now we're going to extend this one to the three terminals. So where is your drain? So this is your drain. So now your drain is connected to your RD and then goes to your V out. And again, this one also will be grounded. How about your source? Source is direct with ground, and then your gate will be connected to your R1 parallel to R2, and then you have your RS, and this will be your input signal VS, and the whole part will be totally ground. So you are done with the small signal equivalent for your common source amplifier. So now what you need to do next, you need to define where is your R out. So here will be your R out. Where is your R in? Is it before or after RS? So it need to be after your RS. So this will be your R in. So this is the final equivalent circuit. So what you need to find now, you need to find your V out, and then you need to find your VS, and finally you need to find your AV. So in order to do that, you also need to find your R in and R naught. So we will see the derivation after this. Okay, so now let's start to derive the voltage gain of your common source amplifier. So if you understand the common emitter, the derivation will be almost the same. So now you're going to start at the output or input. So let's start at the output. So at your output, you're going to find what we call V out equal I out R out. So what will be the current at your output circuit? So since you have a current source here, you will force the whole loop to be the current source. So here will be plus and minus. So when your current entering the minus sign, so it means you need to add here minus GM VGS. So this will be your current. What is your R out? So your R out is equal to, okay, looking from your eyes from here, so your out will be small r small o parallel to your RD. So your V out will be R out parallel to RD. So this will be equation number 1. So now we are done at the output. So now let's see what will happen at the input. So where is your input is this part. So since you have your VS here, so let's erase this. Okay, not erase. So this is your VS here, and you have RS in between. So this one you are going to introduce another voltage here, what we call V in. So when we see from here, your V in here is actually parallel, right, to VGS. So your V in here will be the same with your VGS. Now how you're going to find R in? So what will the value of your input resistance? So looking from here, put your eye here. So what will be the equivalent resistance? So it is R1 parallel to R2. Okay. And then the final part, where since you have a RS here, you need to do what we call voltage divider. So let's redraw the circuit. So here is your input signal. Here you have what we call RS. And here is your R in. And what is the voltage across your R in is actually your V in. So by using voltage divider, what is will be the value of V in is actually equal R in divided by R in plus RS multiplied by VS. So you're going to equate this one. 1 over VS equal 1 over V in R in divided by R in plus RS. So this will be equation number 2. Okay, so now you already got your V out, you already got your VS. Now let's move to the voltage gain. So what will be the voltage gain? Voltage gain equal to V out over VS. So your V out will be from equation number 1, that is minus GM VGS R naught parallel to RD. Now what is 1 over VS? So your 1 over VS is actually multiply by 1 over V in R in divided by R in plus RS. So now let's look at your VGS and V in. Do you know the value of VGS and V in? So from this equation, your VGS and V in are the same, right? Because they are parallel, so you can cancel out each other. Okay, take note, your VGS here will not be the same with your VGS from your DC. Why? Because it's AC and this one is DC. You will remain this one unknown because you're going to cancel out. So your final AV will be equal to minus GM R naught parallel to RD multiply by R in divided by R in plus RS. So what is your R in? R1 parallel to R2. So now you already derive what is the voltage gain for your common source amplifier when your source is directly grounded. So this is what we call type 1 common source. That is source grounded. So now you already find the AV, you already find your R in, and you can find your R naught. So the equations are derived. Okay. So if you have any question, please let me know. Thank you. Assalamualaikum.